So what are communication protocols? This was a really confusing thing for me when I first got started in this industry. It was a communication protocol. What is this? And then I heard different names. I heard of RS-232. I heard of 485. I heard of Ethernet IP, but I just couldn't grasp and understand what it meant. And one of the things that you have to understand, let's say for instance, Ethernet IP. To actually understand the fundamentals of how it works is much more than is required to do anything in industrial automation. You really only need to know how to set the thing up. And so let's dive back into how does this relate to discrete signals? How is it different from a discrete signal? And how have the technologies changed? Well, a discrete signal would be something just an on and off type of signal, right? It's a simple electrical signal that is either you're receiving a voltage or receiving a current, and that is what is determining an on and off state of a device. There's also other things that are like analog signals, which are a little bit closer to what a communication protocol is, where we're receiving a range of voltages or a range of amperages to get a signal. Now, with communication protocols, what this does is it gives us the ability to take a bunch of these discrete signals or a bunch of data packets and put them all together and send them as one chunk of data and be able to do that very quickly. Now, with different communication protocols, what happens there is these communication protocols are structured differently, right? And I'm not gonna give you an exact real-world example of a communication protocol. So let's say, for instance, we're gonna send an Ethernet packet, and we'll compare that to another communication protocol like a Profinet packet, right? This is pure example's sake, and try to get you to understand how these protocols are different from one another on the back end. Let's say, for instance, we're sending this data packet, right? And in the front of the Ethernet data packet, you have a 1. Right? And then you have a bunch of other data. Profinet protocol, you have a bunch of data and then you send a 1. Or let's say one of the differences between these protocols is the way that they send their packet. So in the Ethernet protocol, it sends that 1 as an identifier of here's the packet's coming, right? So notice it's saying here's the packet's coming, and then the other one is at the end, so maybe you're saying the packet has came. So this is just a way on like the back end at the very deep level how these communication protocols are different from one another. Now, on the surface level, what does that mean to you? Well, what will happen with a lot of these communication protocols is the setup will be very different, right? Now, some things are a user interface, which makes the setup different, and other things are a very hard, structured communication protocol. Let's say for something like Profibus. Let's say, for example, for something like Modbus. Modbus has a very structured communication protocol where the data comes in a certain way, right? And what do I mean by the data comes in a certain way? What I mean is, let's say for example, your inputs come in, then your outputs come in, and then your integer data comes in, which means like your numbers. Like let's say for instance, you want to transfer a number 10, that would be in that integer data. And so it's structured, and I'm just giving you a brief example's sake. This is not the exact. You can look up different tables that will identify what these different protocols, how they're structured, right? So not every protocol is not structured in a very set manner as Modbus is. And that's one thing that's really nice about Modbus. You know, no matter what, whenever you have a communication between any two devices over Modbus, that my inputs are coming in here, my outputs are coming in here, my integer data is going to come in here. And so with that being said, things are set up in a very easy manner. One of the challenges with that is your data is set to a certain size, you can't necessarily expand that data, and you also don't have the flexibility to adjust that data. Now let's go with a communication protocol like Ethernet IP. So with a lot of devices, let's say for instance we have a PLC and a robot talking to one another, you're able to adjust those different sizes of data that you want to talk. Now, in the past, this was really much more important because the amount of data that you sent really had a huge impact on your data's cycle time, right? And so if you started sending too much data, you'd bog down the whole data chain and could completely crash your network. Nowadays, it's not as big of a deal. However, I think it's something to be very mindful of. But I think the more important thing today is organization, right? So that way, whenever you develop a system, you develop them in a very repetitive way, and also you build them in a very efficient way. So whenever you define like how many inputs and how many outputs you need in the system, and how many integer data points you'll need for a robot, maybe how many group inputs or outputs you'll need. Now you can set your data size for your inputs and your outputs to match, and they have to match, right? Your PLC data inputs and input and output data have to match the PLC, have to match the robot. They're set up so that those two are connected and talking to one another. So you'll set it up on the PLC, you'll set it up on the robot, now they communicate. And then you have to do that with every single device. So if your PLC is talking to, not your HMI is set up on a little bit different platform, but if you have other additional robots in the system or any other auxiliary equipment, you would have to set up a communication connection between those two devices and set up how much. So again, like one thing that's really nice about this, let's say for instance you have 20 robots in the system, and the most data that's going to be used is 4 words in, 4 words out, and you don't have to know this, but you could have all the robots set to 4 words in, 4 words out, and now all your robots are set up uniformly. You're set up so that you have enough data for your robot that needs the most data, and your data is all uniform across all the robots.